Many of you know that I design and build machines for measuring plant performance. And plant performance is the ability of a plant to withstand harsh conditions or to produce more food. And researchers design experiments and they need the ability to measure without bias a lot of plants in an experiment. And that's where my machines are used. Typically, plants are inserted into one of my machines, images are taken, and then software analyzes those images to extract information, and then machine learning methods are applied to that information. I typically use an off-the-shelf computer to control the machine with a LCD panel attached to the side of the machine with the VISA mounting plate. This works okay, and it's economical. But for this instrument, I wanted to try something different, so I got a panel PC. And a panel PC embeds right into the instrument. So this is one of the panels from the instrument that I've cut a hole out of and inserted the panel PC into. Besides creating a really finished look to the instrument, this computer also has additional I/O that most personal computers don't have. For example, it has 5 RS-232 ports, 2 of which are configurable as RS-485. It has 2 gigabit Ethernet ports, both of which have power over Ethernet, so I can power cameras directly from this computer without a need for a power injector. And it also has 16 GPIO pins, or general purpose I/O, digital I/O pins that are 48 volt tolerant, where you can sync and source and sense up to 48 volts. With the GPIO pins, I had hoped to replace the need for a PLC. I don't need much I/O, just enough to detect when a door is open, to lock motors out, to detect when the emergency stop has been pressed, and to control a few solid-state relays. But the Linux set this fully tested system came with is incapable of controlling this FinTech GPIO controller. Installing a more recent version of Linux, building a custom kernel, I can gain control of the GPIO pins, but just enough to toggle their state. I can't read from them, so I won't be able to use the pins on the panel PC to detect emergency stop or door position, stall state from the motors, and so forth. The panel PC was purchased from Logic Supply, and they've been really great to work with. And I hope that they can solve the problem with the GPIO compatibility, because it's going to affect other people as well. The panel PC has a capacitive touchscreen, and I have a USB wireless keyboard attached to it. Just want to demonstrate controlling a solid-state relay with the GPIO pins, just flashing the lights on off every second. Again, unfortunately, I can't use this to read the emergency stop state or the door state or the motor state. So the GPIO pins really aren't very useful, and I'll be installing a PLC. During the rest of the video, I'll show setting up the lights, installing the panel PC and the switches, and then we'll move all this to the garage and install it into the machine's framework. This is the saw that Evolution donated to the channel. My initial impressions are pretty positive, but I'll eventually do a full review. I like these fluorescent lights. They have a lot of holes that can be used to attach them to brackets. To take a little of the shear off of the screws, the lights rest against alignment pins. Other than the plates made on the drill press, all these parts are ordered from Misumi. I use a Dremel US40 Ultra saw with an abrasive blade to cut the panel. The Misumi cover panels are steel cladded foam, lightweight, really nice panels. The panel PC is held in place with jack screws. I purchased the panel PC from Logic Supply, which has offices in Vermont, the Netherlands, and Taiwan. It was actually hard to find a panel PC that didn't have any ugly logos on it. I want my branding on my products, not someone else's. To make the 22mm hole for the switches, I use a step drill followed by a die. If you've never used these industrial switches, the button is held in place by a backing plate, and then the actual switches are attached to the backing plate. Switches can be normally open or closed and can be stacked to create unique combinations. In this case, we have 3 normally open switches and 1 normally closed switch controlled by a single push button. So, does it work? Well, you'll just have to subscribe and come back later and find out. This is primarily the framing. We started to install the electronics today. The next piece I'll be installed is a power enclosure, which will go into the side. There still is a ridiculous amount of work that needs to be done in the next week and a half, but it's all doable. Paul on the Adventures in Fabrication channel asked if I would be using the panel PC on either of my CNC machines. Unfortunately, this panel PC costs more than either of my CNC machines, so I don't think I'll be owning one anytime soon. Regardless, it gives this machine a really nice professional finished look that I'm sure the owners will appreciate. That's all I have for this video. Comments and questions are always appreciated. See you again in the next video.